Hi guys, we are continuing with our Leetcode and binary search, and so let's continue with the next task. Okay, so I'm sharing my screen. All right, and the task actually the latest time to check. It's not interesting. So you are given a 0 inside integer a bus length each element is a part time of a bus. So you are also given a array of passengers where person J represents the arrival time of a passenger. Bus become unique. All passenger arrival times are unique. And here again integer bus represents the maximum number of passengers can each bus. Passengerize will be a line for next level bus. You can bet on bus at x minutes if you are at great minutes, where x more. Okay, and bus not passenger where with the time on the first. More fully, when bus arrives is captive fewer passengers are fast, they will all get the bus. The passenger with the least will on the bus. Return the latest time. You may arrive at the bus to catch a bus. Better and not the array buses are sorted. Okay, nice. Some array of buses, right? There's bus and this bus represents arrival time, right? So there are the part time of bus, and so each part time of time is, so for example, bus 0 and there's the virgin. Second part at, and we also have buses and each picture represents arrival time and jet. Okay, so one passenger arrives at 2 minutes, and 17 minutes, 20 minutes, and 90 minutes. Also, pass equal to the capacity is the maximum number of passengers that get on each bus. And we have to return the late time you arrive at the bus to catch bus. You cannot arrive at the same time as another. Okay. So we had one bus that can have two, and another 12 that can have passengers. So if like first came two, it says and everyone empty. Another will 17 and 18. So see it on this like later time in this. For me, 16 because something I see it on this right, and yeah, and we're actually both every time 16 10 first with 0 then yeah with and first passenger. Let's take another example. So we have buses like this 10 12 and we have some passenger as well. So we can click on minute, for example, right? Do we have return the latest time may arrive at the bus stop? Okay, bus. Yes, because for example, I 26. So for example, if yeah, is this more into so let's choose for this bus and sort passengers by we have for 11, 13, 20, and we see that we have this passenger set of uh, 3 passengers. So this dirty is actually going on the next bus. So yeah, so the earliest time would be to 20 minutes to sit on the third. Okay, so let's about train. We have our bus lengths. We have bus length. Let's see that to the bus possible. So let's say if we can bus and 1,000 bus. And we also have measures. And so that also we have this one and 10 passengers. Also have capacity. So we can buy the bus at least one that be 100. Let's get constraints that we have. Okay, we have and this and injury. So they all contain the first part. Okay. Each element can be from 2 to and each element in this is unique. Passage is unique. Okay. So then go to solutions. Let's get started. We need to sort this. So we are in house and also our vectors like 4, 11, 13, 15, 26. Yes. What can we do here? So we can go like one, for example, we have, and first we go. Yes, so it was groups and lamp do lamp over time text and over plus word for log and log and log m and m log. So this are time based complexity, but when we do it for like for example, and we check because aware of our passengers as greater than 10 and count how many passengers we can have here and increase this counter. So we have some counter that would be 0, then go through element. With binary search we find a option where we have an element that is greater than the current one. Position 11. And we find how many we have here. So we have our passive equal to 2. And let's say it's we have something like this. As one element here, and element we 3, right? Index, and this means that like we have 3 going on. So it means that count we should count is greater capacity. Sound 3. Means like the next element to make capacity multiply to this, and then like this our capacity on 3, so there's 6 3, we have 3, and we try to find how element greater than 20. So we found that, and this one would be 6. So we see that on the first bus is going this 2%, on the second bus is going this 2%, and on the third bus is going this 2%. And yeah, so we found this element. And then with one loop, we are actually going back and to find the element. So we have, so we have 3 here, but we actually have 6. So we have -3, right? Why we have -3? 0. Oh, yes, 3 minus 3 plus 3. And yeah, 3 minus 3 plus 3, because we already count this 3. So it's here 6 minus 3 plus 0, number 3. So actually we found a place where, yeah, we found a place where the next, where we have all buses settled. But what if we have like this, right? And we found here. So here it would be 7. But we have -1. So with -1, it means we should go in other direction by this number of times. Yes? Yes, and in this case we have all capacity. Okay, but still, do we need this actually? Like, if we have 2/2, like all these buses, right? So we can, it would be 6, like 1, 2, 3, 4, 5, 6, right? So we know that all this no. Yeah, we know that whether they are going to the same bus or no. For example, whether it would work or not, let's check. So let's take this example, right? 4, 5 we don't have. Okay, 5 we don't have. So we can remove this 5. So we have 4, 11, 13, 18 we also don't have. 19, 21, and 26. Okay, so we have what I miss here. 4, 11, 13, 19, 25 also, 25. Okay, so if I sort them, and then I count like 6 values, 1, 2, 3, 4, 5, 6, and then go backwards to find value that would be the greatest. So so here it's 24. Yeah, but 24 would not work, right? So if I have like 4, that is going to this and to this, to this. Yeah, so 24 actually would not work. Okay, so I need something more better one. 10. Yeah, so I need indeed some binary search. So when I have my 10, I will jump to the value that is greater. I will find this 11. Then I can check how many elements I'm left. So here only 1, so it's less than capacity, so I don't actually care. Then I have another one. I jump to 21. I check this number of capacity. And I'm here because I have 1 element left. And Then I go to 30 and I have this one plus one element. So I'm going backwards by 4, and I have here 11 plus 1. Okay, let's check with this example. Yeah, let's check with this example if it will work. So I have my bus is 10, 20, and my passenger 2, 17, 18, 19. Okay, so I found 17 and capacity will be 2. I found 17, so 17 is greater than 10, so I don't care. Then I found 12, 20, so 20, I have okay, I have 3, capacity is 2, and I have 3, but capacity is 2. But I actually can have also like this, right? So I have 4, so I need to jump -2, this one, here. Okay. Okay. So here, actually, to get on the bus, I need to, so result would be 15. But how can I get this? I have 10. I can find 16. I can count how many numbers I have here. Okay, let's try to draw it. So first I have like left pointer and right pointer. So I found like first 10 with 16. Okay, I found 16. Yeah, and it will be my left pointer. Okay. And I see that it will be only one left. So result, but if it's more, for example, for 20, I have 4 elements. And capacity is 2. So I can find the latest element. What would be in this case? So in this case, my latest would be 19, right? So So result would be 20. Or result even would be not 20, but 29. Yeah, it would be 29. Mm. Okay, I will try maybe to solve with brute force, because with binary search I can't see actually how can I do this. So how this brute force would look like. So I have my array, I have another array 2, 16, 17, 18, and 19. So I'm going one by one. So I have 10, right? So when I see a value that is less than my current value, I I see my count, right? Or capacity, it would be 2, right? So I calculate how many values do I have in this capacity. So I have like 2. If if I have next one is greater than 10, but my capacity is still available, so my potential would be 10 minus 1. Potential arrival time. Then I have 20, and I'm count like, okay, I have capacity with 2, and 16 would be my okay. 16 would be my next position. So what does it mean? So I start with 16, then I go to 17, and my capacity is 2. So when I finish with my capacity, like if capacity is 0, but I still have some values, I should take the previous one I should take the previous one. And then, okay, I think that, yeah, that I don't have some idea how to solve it for already how much time. Yeah, I think it's already past about half an hour. So let's maybe check some solutions that we can have here. So we can have some 2-point structure solution. Okay. We are sorting them, okay. Then we are going here. here. So the problem is difficult to implement due to many edge cases. Yes. To make it simpler, we first fill all buses except the last one. Then we put passengers into the last bus, tracking the last passenger and remaining capacity. Yes, so that's actually what I want to solve. So I have my buses, right? Do I have some hints here? First hint, sort the bus. Yeah, so we are doing use two pointers to traverse buses and passengers with a simulation of passengers getting on the particular bus. Okay. So it's actually what we are doing. So we have 10, right? We have 2. Okay, so 2 is getting on the bus. Then we have 16. So 16 is cannot get on the bus. So we have 16. Here we have 20 and we have 16. So we put this on the bus and we put 17 on the bus, right? Okay, then we are break. Then we go. So our latest would be 17 here. And if we don't have 30, our latest would be 17. So what should we do next? The last bus departure time, if we have capacity there, or the arrival time of the last passenger. Okay. Okay. Okay, let's check another one. So it's some greedy sorting using Q and set. Okay, let's try to implement this. This thing. So we found the latest, and then we should found time less than latest. So here it's 15, right? Let's try to check this test case. So we have 10, 20, 30. So we put this one on the 10th bus. Then we go 20. We put this one. Then we have 30. We put this one and this one. And we are going backwards and try to find the lowest. So it will be 20. Okay. So what we are doing here. So first we do erase 30 buses and passengers. Then we are going like finding latest. So latest, let's take latest, it's our passengers 0. So what are we doing here? So we are going by buses. And we have our bus time. Then we go through our passengers. And here, and here, when we go by buses, we should have some pointer with passengers. That would be 0. And here, let's say the latest passenger, and we have also capacity. Here, while capacity is greater than 0, we are doing the following. So our latest would be 0, with 0 index. And we check if passengers, let's say I would be our latest, passengers I is less or equal to bus, we have current capacity. The current capacity is actually, here is capacity over buses lengths. Now let's do it like current capacity will be 0. We will increment this current capacity, and here it would be bus capacity. And why current capacity? Let's say buses capacity is this one. Yes. So we check if while bus capacity is great and this bus capacity is greater than 0, we do this check. If passengers I is less than bus, we are putting. So it means we decrement our bus capacity. We also decrement this bus capacity. And yes, and this I, yeah, it would be our next passenger. Else, we break from the loop. Okay. Okay, so here we actually get our latest passenger. That will be I. And so, for example, in this case, I would be 2, 16, 17, 18, yeah, 15. Should be 15. So our latest here, it's 20. We put this 2. Then we go 18, 19. So we go backwards to find, yeah, so while I is greater than 0, we return yes, we return passengers I -1. So what we are doing here, while I is greater than 0, we should decrement our I. So if passengers on the I yes, if passengers on the I minus 1 is equal to passenger I minus 1, then we are decrementing I and going something like this. Okay, so it's really, how to say, yeah, it's really strange logic, but let's try to solve it. So let's say that we have these buses and we have such passengers. Okay, so we have 0, then we have bus capacity that would be 2. Yes, 2 and 2, so 4. So we take each bus, 10. Bus capacity would be 2. So for 2 greater passengers I is less than bus. So passengers I here it's 2, so it's less. So we decrement our bus capacity by 1, increment our I, and bus capacity also would be decremented to 1. Okay. Then we again check this while loop. We check next passenger, it's 16. So 10 is not greater, so we go out from this loop. We take next bus 16. Bus capacity would be 2. Okay. Here we take again 16. Here 16, 16. Oh, no. Next bus it will be 20. So 16 is less than 20, so we decrement bus capacity by 1, and by also this one, and increment to 2. 17 is less, so we again decrement our bus capacity, and this one would be 0, and increment by 3. Here we check, okay, so bus capacity is not greater, so we break out from the loop and we go out. So our current I is 3, bus capacity Y is 3, it was 4. So we decrement by 1, 2, and 1. Okay, so we have one left in bus capacity. One left in bus capacity. 0, 1, 2, 3. Okay. So currently we pointed to 18. And we check, okay, they are equal. So we decrement I equal decrement I. 16, they are not equal, so we take so we take I minus 1. So it's 15. Okay, let's check. Okay, so we have output 24, but expected 20. Let's Yeah, let's check this example. So we have 10, 20, and 30. And here we have 4, 11, 13, 19, 21, 25, and 26. And would be 0. Bus capacity is 6. Current bus is 10. And here it's 2. Okay, so we are checking 4. 4 is less than bus, so we decrement 5 and decrement bus capacity. Then we take 11. 11 is more, so we are breaking, and we are going to the next bus, that is 20. Bus capacity 2. We take 11 is less, so we decrement 4, and bus capacity we take 13, it's less, so we decrement 3, here 0. And we have 19, but we are breaking, so we are going to the next element. It's 30. 2. We have 19. 19 is less, so we decrement our bus capacity. Then we have 20. Uh, 21. So we also decrement it, and we have bus capacity 0. And we have 25. So we go back and check 25. But it's not correct, because this one went to 20, and this one should went to 30. So we should end up with 21. So let's check once again. Okay, so we have 4. We have 6 bus capacity. Yeah, so this bus capacity actually is not correct. So maybe we don't need this check. Let's do it without it. So we have bus 10, bus capacity 2. Okay, so it's 2 is greater, 4. So yeah, so we increment our I and decrement bus capacity by 1. Yes. Then we have passenger 11. Eleven is not, so we go out. Then we take 20, bus capacity 2, and we check is less, so we decrement this one, increment this one. 13, we decrement this one, increment this one, go out, and we have 30. So 30 is, we have 19, so 19 is less, so we decrement this one, go to this one. We have 21, decrement this one, and increment this one. So in the end, we finish with 21. And then, yeah, we go forward, back. Check. 24. While it's still 24. Should be 5. 0, 1, 2, 3, 4. Ah, it's 5. Okay. Yeah. Mm-mm-mm. Mm. Yeah, so whether we should take this or take this. There's two edge cases actually. Oh, hmm. Yeah, if it's not enough, then we should take the latest. Yeah, I think, yeah, I couldn't change it. Solve it, sorry.